Oh, hope everybody had a good spring break. I know today that we worked a little bit on surface area and breaking down rectangular solids into the different sides that make up that rectangular solid. And I also talked to you about a Rubik's Cube and how we're really trying to find all the little stickers that you would put on a Rubik's Cube. That's like finding the surface area, is putting all those little stickers all over a Rubik's Cube. So that's what I want you to think of when we're doing this. Today, however, it was very easy for us to figure out the surface areas because basically we just took, the sides that had this cubes like this, and they gave them to us, and we just counted 1, 2, 3, 4, 5, 6, 7, 8, 9. So this might have been the front, and the front, had the area of 9. And then we calculated the side, okay, which would have been the same because we decided to let's just chalk it as a cube. Okay, and 1, 2, 3, 4, 5, 6, 7, 8, 9, also 9 on the side. And we also talked about the fact that, you have an opposite side to each one of these, like the front that matches, but we can't see it because it can't be drawn that way. So if you were talking the front matches the back that we can't see. So if you knew the area of the front was 9, then the area of the back is also 9. Just like on the side that you see here, there's another side, we call that side 2, and we talked about that in class, that if this side 1 is 9, then side 2 is the same. And then you, of course, have to do the top, and let me draw that in real quick here. I know this is not a great picture, but you'll remember because we did this in class, and if you counted up the squares that are on the top, you would also find that this is 9, and the top matches the bottom that we can't see because that's what the figure is actually on. But because the top is 9 and this is a rectangular solid, then the bottom is also 9. Then if we want to know the total, total from your preschool days, maybe not preschool days, kindergarten days, as total is meaning add. So we just basically are going to add all the sides. There are 6. So we should have 6 numbers that we're adding together. 1, 2, 3, 4, 5, and 6. I'm going to go ahead and, since they're all the same, I'm going to do 9 times 6 because there's 6 of them. And I know that basic fact of 54. So the area of my brown box right here, my cube, okay, is 54 square, because if we put squares on them, units. Okay? So it's the same idea of what we're doing tonight, except for the fact that our rectangular solid doesn't have squares on it. It only has the dimensions given. So it's a little bit different, but you're going to figure it out the same way you do with the squares that we did today. Okay, so what I was talking about just a second ago was that now our figures only have the dimensions listed. For example, our first figure here is 4 high, 3 on the bottom, 2 on the bottom here, and we're going to talk about these lengths. So because the squares on there, we can't count them. So we're going to have to use our know that area is the length times the width, and know that we're simply adding all of the areas that make up this figure. So let's break it down. Let's talk about just the front of this figure. I'm going to shade it in blue. Okay, so the front right here, the front. What are the dimensions of the front? 3, 4 by 3, right? That's what I mean when I say dimensions. It's 4 inches tall and 3 inches wide, so therefore it's 12 inches, okay? And that's the front. What do we know about the front? And another side that's identical to it is that the back of this figure, it's going to be the same. Otherwise, this would be very weird shaped because they have to match. So your front matches your back. So your back is the same dimensions, and that is 12 inches also. And these are squared because remember we're finding area here, so square inches. Now, let's do our side in, say, a light green. Okay? Our side here is the side that you can see, and I'm going to call it S1. S1. What are the dimensions of our side? Well, they don't give us this length right here, but if you know that this length here is 4, then that means this length right here is 4, which means this length right here is also 4 inches, okay? They go around. They have to be the same or this would be a lopsided figure. So our side here, the green, is 4 by, you know what? 2, exactly. So just this one side is 8 inches squared. And it's going to have a matching side that we don't see. It's over here. We can't see it though because we only see 3 sides of the figure. But the side 1 is going to match side 2. And its dimensions are the same. So we don't really have to do much math here. We're just copying over. Okay? And then finally, we have the top. I'll do that in orange up here. Okay? And our top is going to match our bottom. So looking at the dimensions of our top. Now notice there are no numbers here, but do you know the dimensions of the bottom? Sure, they're right here. Okay, it's 3 by 2. So if we know the dimensions of the bottom, guess what? We'll do that first, and they're going to match the top. 3 by 2, which is 6 inches squared. And then our top is exactly the same, 3 by 2, 6 inches squared. Now remember what we did on the last one? We added them all together. So our total surface area is going to be the two 12s added together. 12 plus 12, 8 are 2 sides, and then our top and bottom, 6 and 6. We're going to add all that together, and when we do that will be the total surface area. So it looks like we've got 20 with the 8s and the 2s, that's 20, plus that is 32. Carry 3, and we have 3, 4, 5, 52. Now let's double check. This is 20 plus 12 is 32. Yes, inches squared. So that's really all it is. It's like you're wrapping a package. You're putting paper on the outside. How much paper would you need? If your paper was in little cubes, or little, not cubes, but little squares, like you're on a Rubik's, see how there's different squares here, like this. We could just simply cut them, making sure they're squares, and then just put them together like a mosaic. Or if we're trying to do something where we're not using squares but need to fit into the spaces over here, if I wanted to cover this, I would make right here, this square right here, or this, it's a rectangle actually, I would make it 4 by 8, or 4 by 2, so that it's 8 square inches that go on this green side right here. And then if I wanted to cover the front, I would make something that was 4 by 3, or 12 square inches for the front. See what I mean? So basically it's like you're covering this. You're using two-dimensional shapes to cover a three-dimensional figure. All right, let's do one last example. You try it, and then pause it, and then check your answer. All right, so let's use a real-world problem here. We have a shoebox with the dimensions of 8, 5 by 9 inches. And we want to know how much paper are we going to need to cover the box, because we're going to put our present inside of it, and we want to put paper on the outside. So the first thing I'm going to do is I'm actually going to draw a picture of this box. All right, so I've drawn my picture. Then I'm going to break my box into I know it's a rectangular solid, so it has 6 sides. So I should have 6 different numbers that I'm going to add together at the end. So let's do this like I did before, where I color-coded. I'm going to do the front of my box. The front of my box is right here. What are the dimensions of the front? And I'm going to break them out. I'm going to actually just do the math. This is the best way to do it. The dimensions of my front look like they're 8 by 5. So 8 by 5, or 8 times 5, would equal 40 inches squared. Okay? What matches the front? So I don't actually have to do any math. I just copy this over. Did you say back? Then you are correct. So the back of this box, which is right there, we can't see it, is 8 by 5 also, making it 40 inches squared. Okay? Now, let's move to the side of our box. The side of our box is right here. Okay? We'll call this side 1. Side 1, when we look at it, we know it's definitely 9 is one of the lengths, but what's my other length? Is it 5 that makes it up, or is it 8? Well, remember that over here, if this is 8 right here, then this is 8, and that makes this 8. So we would therefore use the 8 instead of the 5, because it's those two numbers. So if I do that, and I know my basic facts, I know this is 72 inches squared, and that's going to match which side? Side 2, which is this side right here that you can't see. Side 2 is also 9 by 8, or 72 inches squared. See, it's pretty easy. Once you really only have to do 3 calculations here. Well, 4, because then you have to total at the end, but really it's only 4 instead of it looks like 8. All right, now we're going to do the top, and I'll do that in orange. And the top right here, what are the dimensions of our top? Well, if you're not sure, then look at the dimensions of the bottom. Let's do that one first, because I can definitely see the dimensions of the bottom. My bottom is 9 by 5, so 9 times 5 equals 45 inches squared. And then my top is also 9 by 5, which equals 45 inches squared. All right? Okay, now all I have to do is just total all those up, which I'm going to do now for you. All right, so you add your two 40s, your 72s, and your 45s all together to get a total surface area, because you're covering the outside of this, and you're going to use 314 square inches, or inches with the little 2, however you want to write it. Remember, I told you there's several different ways you can do it. It's whatever you want to do, but make sure that you are indicating that it's square inches. All right, and that's basically it. So we'll practice tomorrow in class. Make sure you take the notes and answer the questions, and have a good night.